Previously, we have dealt with games of complete information where every player knows the payoffs of the other players when they make an action. In this tutorial, we deal with games of incomplete information. Let's first take a look at a well-known example of game of incomplete information called Market for Lemons. The Market for Lemons was awarded the Nobel Prize in Economics in 2001. And what we have here is a simplified version of the original model. Now, suppose that there are two players, a seller and a buyer. And suppose that a seller has a used computer. The seller decides whether to sell the computer for $250 or not, and the buyer decides whether to purchase it at $250 or not. The seller and the buyer simultaneously choose whether to trade or not, and the transaction takes place only when both players wish to do so. Now, we assume that the seller knows the quality of the computer while the buyer doesn't. This is a natural assumption given that the seller possessed the computer for a while and probably knows how well it works, while the buyer has to decide whether to purchase it or not without knowing much about the quality of the computer. And so the seller is likely to know the value of the product, while the buyer is unlikely to know the value of the product. Now, while we assume that the buyer does not know the quality of the computer, we assume that the buyer knows that there is a 10% chance that the used computer is of low quality, and there is 90% chance that it is of high quality. In the low quality case, the item has the value of $0 for both seller and buyer. But in case the product is of high quality, the item is worth $200 to the seller and $300 to the buyer. This game is summarized in the two tables shown on the slide. Here, the seller knows exactly which game he is playing, while the buyer only knows that there is 10% chance of playing the game on the left table and a 90% chance of playing the game on the right table. The buyer sees that the seller plays the game on the left table 10% of the time and the right table with 90% of the time. Therefore, there is an information asymmetry in the sense that the seller knows which game he is playing, while the buyer only knows the probability distribution of the games. This game can also be written in the game tree shown on the slide. First, the nature chooses whether the quality of the used item is low or high. Unlike the normal player, the nature decides low or high randomly according to the given probabilities. These choices made by the nature are called types. So the seller can be in the low information set where he is a low type that sells low quality computer, or in the high information set where he is a high type that sells high quality computer. Then the seller knows whether he is a low type or high type and chooses whether to sell or not. Finally, the buyer decides whether to purchase or not. Note here that all of the buyer's decision nodes are contained in a single information set. And this means that the buyer does not know either what nature has chosen or what the seller has chosen. In other words, the buyer has to make a decision without knowing the seller's type. The situation like Lemon's Market described earlier is an example of static game of incomplete information. And the static game of incomplete information is sometimes called a static Bayesian game, which is also sometimes simply called a Bayesian game. A Bayesian game consists of a set of players, a set of actions, and a set of types chosen by the nature, and the probability distribution of all types, and the payoff functions of all players. As noted in the middle of the slide right here, an important feature of Bayesian game that was not present in the games of complete information is that the payoff function now depends not only on the action profile, but also on the types. Okay. And so a strategy in a Bayesian game specifies what each type of each player does, such that a strategy of player I is a function of its own type. The problem of Lemon's Market is formulated as follows. There are two players, a seller and a buyer, denoted by cap S and cap B. The set of actions that the seller can take consists of sell and do not sell. The set of actions that the buyer can take consists of buy and do not buy. There are two types of sellers, low and high, while there is only one type of the buyer, which is denoted by 0. The probability that the seller is of low type and the buyer is of 0 type is 0.1, which is written as P of L0. The probability that the seller is of high type and the buyer is of 0 type is 0.9, which is written as P of H0. The payoffs are given by the payoff matrix described previously. Now, in the Bayesian games, the action and strategy are different from that of games of complete information. The seller's strategy is to determine which action to take depending on whether the seller is low type or high type. For example, the payoff of the seller, where the seller chooses to sell and the buyer chooses to buy, when the seller is of low type, is 250. Note here that the buyer type is omitted because there is only one type of buyer. Here, the buyer has two strategies denoted by SB, which is identical to the set of buyer's actions. On the other hand, the seller has 4 strategies because each type of the seller has 2 strategies. Okay, so 2 times 2 equals 4 strategies. The 4 pure strategies are described by all possible combinations of actions that the 2 types of the seller can take. For example, the first strategy, SS of L equals to sell and SS of H equals to sell, means that the low type seller chooses to sell and the high type seller also chooses to sell. The second strategy, SS of L equals to sell and SS of H equals not, means that the low type seller chooses to sell while the high type seller do not sell, and so on. In other words, sell when low type but not when high type is one strategy. Sell when high type but not when low type is another strategy of the seller. It is important to keep in mind that action and strategy are different in the Bayesian games, even though the players move simultaneously.